Okay, this question asks me to describe the transformations from the parent equation y equals absolute value x to the equation y equals negative 1/2 times open absolute value x minus 5 close absolute value plus 3. Okay, just like in transformations 1, I'm going to start by doing a quick sketch of the two equations, the graphs of the two equations. So let's get our coordinate plane. We'll call this x and this is y. And I'll graph the parent equation first, this y equals absolute value x. And again, our vertex for this is 0, 0, the origin, because nothing's being added to the x inside the absolute value, so the x component of the vertex is 0, and nothing's being added out here, so the y component is 0. So right here's the point, the origin. The slope to the right is 1, the right-hand branch, so the right-hand branch has a slope of 1, and the left-hand branch has a slope of negative 1. The axis of symmetry for this, of course, is x equals 0. Okay, let's go ahead and graph the equation we're trying to get to. So it has a vertex of 5, 3. Remember, this is x minus 5, so the x component of the vertex has to be positive 5. It's the opposite. If you view this as just simply a number, you don't view this as minus 5. If you view this as negative 5, then it's just the opposite of that number. And the y component stays the same if you view this as a number instead of just plus 3, so it's positive 3. So the first thing I'll do is plot the vertex, 5 to the right and up 3. So 1, 2, 3, 4, 5, and 1, 2, 3, right here. Okay, and the slope of the right-hand branch is negative 1/2, so I'm going to go down 1 and then right 2, 1, 2. And then I'm just going to use the axis of symmetry to get this other point. So that match this distance up over here. Well, I'm going down 1 over 2. It should be right here. Okay. So this graph actually should look much wider than it does. This green graph should look wider than the blue graph. So let's describe how to get from the blue graph to the green graph. The first thing I'm going to do is shift it to the right 5. Shift the vertex of this. If I go over 1, 2, 3, 4, 5, I'll be sitting just underneath this graph. So that's shift is translation. So this is a horizontal translation. Horizontal translation right 5. Okay, so that'll move the blue graph over here to the right 5, just underneath the green one. Then I'm going to dilate it. I'm going to shrink it vertically. It's going to come down, instead of being at 1 here, it would be at 1/2. So it's going to be a vertical dilation by a factor of 1/2. So vertical dilation by a factor of 1/2. So I've shifted it to the right 5. I've shrunk it vertically. And now the other difference between these two graphs is this one's opening down and this one's opening up. So I need to reflect this over the x-axis. So I'm going to go ahead and reflect it over the x-axis. Reflect over the x-axis. Okay, and let's go ahead and get a visual of what these three things will do to this blue graph. So I'll put that in red. So it's going to go to the right 5, 1, 2, 3, 4, 5. It's going to be shrunk by a factor of 1/2, and it's going to be flipped over the x-axis. So at this point, it's going to look like this. So it looks almost identical to the green graph, except for it needs to be shifted up vertically. So remember, shift is translation. So it's going to go up, so that's vertical. So vertical translation up 3. And now you have the solution.